Yeah, today I'm going to talk about the MSVR program at Microsoft. It's the Microsoft Vulnerability Research Program, and the title talks how to be a finder as a vendor. So if you happen to work at a company that produces a lot of products, a software company, for example, sometimes you work with a lot of other products while you're developing, and you will run across bugs in very certain cases. So this is how the MSVR program works at Microsoft, how our coordination with third-party vendors works on a standard basis, and how you could create your own in your own company. So my name is David. Couldn't be here today, but he is the manager of the MSVR program. He likes to say he likes authentications, hates passwords, meaning he's working on new ways to handle authentication that don't depend on humans generating and remembering text. So that should be handy in the future. I'm Jeremy Brown. I've been a MSVR contributor since 2011. Likes bugs also. I like to make sure my software is secure as well. So the agenda, what is MSVR, how the process works, and how things can go wrong. I know that's always interesting to people. You like seeing other mistakes and seeing how you can improve upon them from that. Also, a couple case examples, a couple bugs that were submitted through the MSVR program. I'm going to talk about some technical details behind those, how they were found, and how they were confirmed, exploitable and all that stuff. And then some lessons learned about, what we learned in the process so far. So what we're not covering, just to make it clear, it may sound confusing. You hear Microsoft Vulnerability Research. It's very ambiguous until you get an explanation. So not how Microsoft handles third-party vulnerabilities that's with their products, not talking about that. Nothing in the queue for public release, of course, or the ethics of disclosure. Everyone has a philosophy, should respect everyone else's, and not talking about that in this talk. So what is Microsoft Vulnerability Research? It started in 2008, founded by Katie Mazuris. She definitely does a lot of Microsoft security outreach, so you should be pretty familiar with the name, Black Hat, a lot of different conferences. It was announced at the Black Hat conference in Vegas, and it came about because there was a lot of MSRC cases that we were getting that they were affecting many other vendors besides Microsoft. Maybe people were doing it in the same way or a similar way, so we needed a way to make sure a lot of other vendors, especially the ones we work with, were finding out about these bugs and getting them fixed as well. Also, of course, need a way to coordinate with other vendors because when you release fixes, there's a process with releasing Microsoft fixes, and then every other company has their own process, of course. So we need a way to coordinate to ensure fixes actually materialize for bugs. It's easy to submit a bug, file a bug, but actually getting it fixed and getting things followed up on is a different story sometimes. So MSVR isn't. It is not MSRC. Acronyms are everywhere at Microsoft, so it's easy to get them confused, especially when they're 4-character, 3-character, even 5-character sometimes. MSRC, if you're not familiar, is Microsoft Security Response Center. They handle bugs in Microsoft products. So you submit a bug to MSRC, somebody reviews it, and we determine how critical it is, how the fix goes along, all that stuff. It's not the Microsoft bounty programs. So there's been a lot of bounty programs materializing from different companies. Microsoft itself has done some for IE 11 preview, different more fundamental mitigations for exploits and stuff. MSVR has nothing to do with that part. And it is a HackerOne. HackerOne's kind of a new, they call themselves the host of the Internet Bug Bounty Program. They're really trying to get a lot of vendors on board with doing bug bounty programs in order to pay researchers for finding vulnerabilities in the programs. So according to them, rewards friendly hackers who contribute to a more secure internet. They cover even some open source software as well. That's a pretty interesting program if you haven't heard of it. And it's sponsored by both Microsoft and Facebook. So it does have some pull behind it. So what is MSVR? If it's not any of that, program to help Microsoft employees report security vulnerabilities that they find in third-party vendors. Third-party meaning anyone but Microsoft in that context. They're there to provide assistance to finders, to answer questions, ping the vendor. Of course, there's a security contact database. Once we work with a lot of companies, we develop relationships with them, and we're able to quickly find security contacts in case they're not that publicly available. Also, the resources to find contacts if they don't exist, which happens a lot with new companies, new bugs companies we never worked with before, or maybe it's just an open source product that doesn't have it's just kind of an ad hoc team. We have the resources to track those down and try to find the right people to get the bugs fixed. Objectives, definitely want to prevent miscommunication. That's a big thing when you're reporting bugs. Sometimes things can come off and don't go the way you planned, and that's a big thing with MSVR, is making sure both parties are happy with communication, with the fixes, and the bugs actually do get fixed from finders, and they aren't ignored. And transparency, yeah, also a big deal. So there are MSVR advisories. There's a dedicated space for this, and it archives all the vulnerabilities, fix information, what's vulnerable. A standard advisory, I'll give you an example in the next few slides, but each advisory, of course, credits the researcher, unless you want to be anonymous. Definitely respect that aspect. So why would you focus on third party? Why would Microsoft have an organization focusing on third party vulnerabilities? Well, it runs a lot of third party code, pretty obvious. And only secure is your weakest link. I know that's been beat to death, but it's very relevant in this. So Adobe Reader, Oracle, of course, they account for a majority. You can look up statistics. Not just PC software either. There's routers and data centers, firmware in the devices, apps in the software stores. There's a lot of things that can, it's not always exploit Windows, but exploit programs on Windows to get on the computer. And often vulnerabilities affect Microsoft too. Once you have a protocol, you implement it. Sometimes they're implemented pretty similar. We find out with the DNS vulnerabilities and stuff. So definitely, it even opens up a door to make our own products even more secure by looking at third party. So goals. Want to ensure people at Microsoft behave the same. In that context, it's not about trying to force companies or people to work with us, but just to make sure that if you get us a bug, we're going to do our best to try to get it fixed, or try to coordinate get it fixed, and we want to provide transparency on both sides. It's not responsible disclosure. That's been gone for a while. That's very subjective, and we're calling it coordinated disclosure because it's much more fair in that aspect, coordinated between both sides. Also want to provide reproducible and interesting bugs. Sometimes you come across a bug and you're all excited, and it's like, well, now you got to write up a document to explain to everyone else what your esoteric knowledge and what you just found. Not always exciting, but definitely it's going to help when you want to get the bug fixed. And also help the finders out. Make sure the bugs do get fixed, which is a lot of goal of a lot of the finders is actually get the bugs fixed. That's why you turn them in. And release advisories, crediting the researcher. So if you like that, that's definitely a goal of MSVR. Help build the ecosystem around Microsoft products. Like I said, a lot of third-party code. Want to make sure everything's secure. And build relationships with other vendors. They can come in handy, especially if you want to get bugs fixed. Relationships are very handy. So who are the finders at Microsoft? Are they just people who find bugs for security hobby? Are they product groups? Well, they are both. They're product groups just maybe working with a third-party product to find bugs. They're people who just like finding bugs. Like, for example, me, I'm kind of in that category. I just like finding bugs, and I'm interested in that kind of research. So that's how I contribute to MSVR. And then product groups hitting one-off bugs. It's not uncommon to hit a bug in a third-party component when you're just testing it, and with security impact. So which ones are eligible? If they're found by a Microsoft employee, if you're doing this in your own company, of course, it'd be by your own employee. Whether they're found on their own time or otherwise, using the company resources or not, and I'll speak about this a little later. The ones we focus on are the critical and important on the SDL bug bar. You can look that up, and it's got a whole scale of It shows you which ones fit into which category. Affects the product on a Microsoft platform, so we're not really focused on iPhone apps, but if it's in the Windows App Store, definitely interested in it. And they're not hard rules. We just want to make sure the program is successful and don't want to waste a lot of time on maybe there's not critical cross-site scripting somewhere. We want to focus on more of remote code execution ones. We put more priority on that. MSVR requirements. So I told you I spoke a bit about the company resources or not. Microsoft employees are required to use a coordinated vulnerability disclosure. Most notify MSVR of vulnerabilities they find, but also if you find it on your own time, not using company resources, you are eligible for bug bounties and other things like that. So a lot of times it's easier, especially for me, for example. There's a lot of resources in Microsoft. We have a lot of good fuzzers and other things, a lot of good tools to find bugs. So it wouldn't be eligible for that. But if I found something on my own time, not using all the resources we have in Microsoft, then I would be eligible for a bounty or other, go through ZDI or some other broker for that. Yep, exactly what I said about the third-party bugs. So, MSVR process. Step 1, report the vulnerability. Pretty obvious. What can happen if this goes wrong? Well, just look at any Windows 0 day accidentally, incidentally in the last 20 years. That's not exactly coordinated in this context. Step 1, ensure quality. Want to make sure all the details are present. So, like I said, it's much easier to get the bug fixed if you can hand something to the company, which goes to the developer, who's responsible for the product, and they can fix it without having to spend hours trying to figure out what the actual problem is. And then we'll go back and forth between the Finder and make sure they are including all the details so we can get everything fixed as quickly as possible. Misfire, not a bug. Some things look dangerous, maybe part of a user error, but just aren't a bug. Part of this numlock example, not really a bug, but kind of mischievous, I guess. Step 3, pretty important part for MSVR. Somebody submits a bug in a third-party product, and we work with the vendor to fix it, and everything's fixed. We release it, and then we're like, well, now that we look at it, we figure out a Microsoft product's actually vulnerable to this too. So someone else figures that out, all of a sudden it's a whole different scenario, whatever their agenda is with it. So definitely want to check if it's an SSL bug, does it affect our SSL stack? We do put in the time and research to make sure third-party vulnerabilities, if we're having similar implementations, that we get those fixed as well. And then we can coordinate with third parties to align so we're not zero-daying each other, for example. Misfire, we zero-day ourselves. Quite a segue. Microsoft, this completely hypothetical example. We find a bug in some online ad network, just like Bing's, and we thought it'd be okay because we didn't mention Bing. Well, now Bing's vulnerable, so again, hypothetical example. Step 4, report the vulnerability. We have security contacts, like I said, from the vendors. Send them the details, encrypt it. Hopefully they're using encryption. Perhaps explain to them what a PGP is, if necessary. And then make sure we're safe when we do share the information. Misfire. Send an email to the company. What's your customer ID? We don't have one. Well, we can't really help you. So that's unfortunate, and I actually think there's some examples of that happening before. So finding the right person, having a security contact is important in these cases as well. Monitor. So part of MSVR's responsibility is to keep the Finder and company up to date with maybe the Finder found a variant of the vulnerability, or maybe the company is fixing the vulnerability. The Finder want to know about that. So provide transparency, monitor, see what's, if there's any release of it, and then the company or the Finder or whatever wants to do a blog post with more technical details, coordinate all that stuff. Misfire. We emailed the vendor, oh, that bug, we patched it, we just never told you about it. It's not very good for morale for the finder. He's like, what happened? He's waiting on a response. Step 6, actually ship the update. Pretty important. And implore them to credit a researcher. Some companies have different policies. Some of them conveniently may forget, hypothetically. If they forget, we'll ping them and remind them again. No credit. Here's our fix. Hey, I found this bug. How about a line about thanking me or something if you're interested in the credit for a vulnerability. MSVR advisory, released most of the time. The caveat is released when we think there's a bug particularly merits Microsoft customers' attention, but most of the time this happens unless there's some other aligned approach. So this is an example of one of the vulnerabilities pages, an advisory from Microsoft. This was a Cisco security service found by, I think, Tom Gallagher. I'm not really sure. But this is an example of what the advisory looks like on the Microsoft website. So now into the technical part a little bit. Hopefully I have some technical people in here. Okay, so these are a couple case studies. The first one I mentioned was libav-codec. The other was VMware Player. So libav-codec, it's MSVR 12017. It's available on the website if you want to look it up. This was found by fuzzing VLC with WMA files. Sounds pretty painless, right? Obviously, easier to find the crash than figure out what caused it. It's pretty easy to just run a fuzzer against a target, assuming there's not a lot of setup involved, find a bunch of crashes, and just ship them to a vendor. But that takes a lot of the vendor's time. They're sorting through the crashes. If you can actually triage and actually figure out what the vulnerability is before you submit it, it's going to go along a lot faster, and they're going to be more apt to pay attention to your bugs. It's almost like a reputation thing with the vendors of, oh, we see something coming in from this person. We know maybe okay quality, may not, but if we see something from this person, we're going to have our team fixing it, get it fixed out as soon as possible because we know that they do pretty good research. So with this one, Bank Exploitable says write AV. Okay, it's a pretty good start. And it's in libav-codec. So fuzzing VLC is a media player, if you're not familiar. So it's going to employ a lot of different libraries, a lot of different codecs for stuff to parse different media files. And this one was actually in a library called libav-codec, which provides audio, video codecs, a bunch of different things. So the bug wasn't actually in VLC, but in the libav-codec. So that was good to know, because if we send to VLC, now they have a crash they have to look at, and they're saying, okay, it's not in VLC, it's actually in libav-codec. Just another speed bump. Now we have to send everything to that team, to a different team, and coordinate from there. So let's diff to see what the fuzzer changed and what the template and repro file look like. So you probably can't see that well, but on the bottom one, on the bottom example, on the bottom of it, you can possibly see that it changed 01 to 07. It changed 1 byte. I don't know if it's a byte yet, but it changed 1 value. So what does that actually mean? Okay, see, 1 was changed to 7. Maybe it's a byte, maybe it's a word. Unless you know the file format, unless you're looking at it through a parser, you don't really know what it is. How do I already know it's a word? Well, there's a tool from Microsoft called Offiz. It's a Office visualization tool, and it takes different templates. Kind of think of it as a 101 editor, but perhaps it was originally written to view Office files. So as far as I know, there's not a lot of 101 editor templates for Office files. So when it's released, it takes different templates to allow you to apply it to different formats that may not be publicly available as much in other formats, such as 101 templates. Free public version on the Microsoft website. And there's also, at Microsoft we use it, and you can create your own templates. So people want to describe a file format, send the gut template around, and load it up in Offiz, and now we can actually see what the value is, what's changing in the program. So again, not sure how much you can see this. but there's a value. We figured out it was the ASF format. It's a container in WMA files, and it was actually changing the number of channels. Changing the number of channels, which tells us it's a 16-bit value. It's a member of the wave format EX structure, and the number of audio channels for this content. Pretty descriptive. Also, saw that when we're testing 03 through 08 causes the crash. Also, if you change to 09, VLC displays an error about how it doesn't support WMA2. So you actually learn a little bit more about the other format just by trying different values in the file. So once again, the point of this is it's easy to find a crash, easy to submit a random crash in a program. Actually triaging and doing some exploitability analysis on it, at least the minimal amount, is really helpful, because now the developer at the company, once you send them this information, they see the diff, you're like, okay, they've already did all this stuff for me. Now I can just go find the code that has this, go find the code with the bug in it and change it. I don't have to go and figure out, okay, I don't have to spend time in a debugger figuring out all this stuff beforehand. So this really helps to speeding up the release process, getting fixes out. So the more information you provide, of course, usually the easier it's going to be. And if you can see the stack chain, didn't really have the full stack trace available for here, but there's a pop EBX, call DWord, EBX plus 30. Anyone else, you have some control over EBX, that's could be remote code execution vulnerability. So pretty promising, and from there, send it off to MSVR. Package everything up, have all the deliverables, route it up to MSVR, and then from there, they assign a case number. You get a case number back to track things. They handle all the coordination. So that's important in the program. If you want to start this in your own company, you really need to have these specifics of who's doing what responsibility is on the finder, and what responsibility is on the organization, such as MSVR or ABCD VR, whatever your company may be. So in this case, MSVR handles coordination, status updates, all the questions, and they literally just provide the transparency and the communication back and forth between you and the vendor. This vulnerability, for example, was patched in May 2012, and a few months later, vulnerability was released. And that's the end of Loop AB codec. And here's the advisory for that one. So you can see overview, executive summary, mitigating factors. So let's say VMware vulnerability. So this is the next one. Vulnerabilities in VMware OVF tool can allow arbitrary code execution. So this one took a little more research to find. For example, how many of you know that VMware can load OVF files? Just raise a hand. Anyone? Okay, a few people, some experience with VMware. OVF, when you say VMX, you say VMDK, you kind of associate them with VMware, but OVF, I guess a little newer format, a little less known about it. But you think about, okay, I'm going to fuzz, VMware, I'm going to fuzz whatever. You assume VMX files, whatever, if you're doing file format fuzzing. But if you're, it's hard to get a handle on which ones the program's actually going to parse unless you do some research beforehand. And even if you do figure out which ones they parse, how do they parse it? Do they parse it internally within the program? Is everything consolidated into just vmplay.exe? Or is it calling an external program? Or is it even passing it off to a web service and parsing it from there? That kind of research takes you from, well, I don't know how to do this, or I don't know how to audit this software, to I know exactly what to do, and I can efficiently put some effort into finding bugs in the software. So, what is OVF? The open virtual machine format, open, secure, italics, secure, portable, efficient, and extensible format for packaging distribution of virtual machines. You can read more about it on the white paper. Too long didn't read, an XML-based file format for describing virtual machine data. and since XML implies describing, conceiving untrusted data, you probably want to audit VLC, or I'm sorry, OVF files. So that's the next part. How does VMware load OVF files? Our handy sysinternals tools can show us that it's actually not internally. It's actually calling ovftool.exe and parsing it from there. Okay. What is ovftool.exe? Obviously a tool for OVF files, but until you actually figure out, until you actually see this, you would maybe assume the vmplayer.exe would be parsing the files. So upon loading it, it executes OVF file. So what is OVF tool? Next step. You're gonna find it on the system. It looks like a tool for loading OVF files, converting them to maybe VMX files, and getting you able to open and run these files. So, step 5, find an interesting crash or unexpected behavior. Format string bugs, they're really popular in the early 2000s, but were killed pretty quickly. And killed, not to say all of them were dead, but they were hunted to near extinction because they were so easy to find. Go find a formatting string function, and go look and see if it has a specifier, and then go from there. They're pretty easy to kill out because of that. A little different than memory corruption, other kinds of memory corruption vulnerabilities. But for this one, literally in the XML, SMS, OVF envelope property, in this way, the folks are mutated it to show %n when we found the crash, but it could be %p. For example, this was part of the test case. We load in VMware to find the bug. So we take this, load in VMware, and we get this nice dialog. Shows you all the pointers in VMware in that context. So just by doing the little extra research of saying, okay, I can't just open vmplay.exe and find the bug. I actually have to figure out what loads OVF files, and it actually was handing off the OVF tool to converting it and then running it in VMware player. And there's the example of the vulnerability advisory for VMware. So lessons learned. Vendors range greatly in their capacity. That's something to keep in mind when you're submitting bugs. Like we were talking about before, some are just, if it's open source software, a lot of times, if it's a smaller project, maybe a not very popular library, it could just be an ad hoc team of developers working across the world, and they may not have the most time in the world. They may have other full-time jobs, so they can't exactly get to things that quickly. Or maybe they're really focused on the product or on the project, and they really want to get things fixed. So keeping that in mind when submitting bugs, it is important to know when it's going to get fixed and what kind of expectations to set with each vendor. Small development teams, very responsive, some are not. Some companies mire you in bureaucracy, so it's important to keep in mind. Setting limits. If you go pen testing the web and dump hundreds of bugs for unimportant sites, we do accept bugs for websites as well from Microsoft researchers, but it's going to really bog down the program when we're out chasing contacts for all these not exactly high-profile websites. Or low-severity bugs. Everyone has their own way of looking at bugs. Some would call something low severity, some would call high severity, but setting limits is important. Employees, of course, like this program. They get to hunt bugs in their free time, or maybe one of their responsibilities when they're testing a product, and they get public credit for it. So employees definitely like the program. And why you should run your own MSVR. Give employees the standard end-to-end process for getting bugs fixed. A lot of times, if you don't have a program, an MSVR, and there's not a lot of coordination throughout the company, you're just pinging things back and forth, and there's not a lot of things can easily go wrong when you don't have a standard process for doing it. Inter-company bug reporting can be, like I said, coordinated and efficient. It doesn't always have to be outsourced or just done alone by the finder. Relatively cheap to run, according, I guess, to the size of your company and other factors. but definitely high return on investment. Definitely, at least for employee morale, and just being able to have a standard process for doing things and keeping yourself out of getting jams, because there are procedures for it. And securing the ecosystem. Likely your product depends on something. Windows, third-party code. Your product shares an environment with, or likely shares an environment with a lot of other programs, and you want to make sure your customers are getting the most secure thing they can. We like to see, I guess, from our own finders and from the companies we report. This is just, like I said, the lessons learned. So some of the things we saw that maybe could be improved on when we're submitting vulnerabilities. Clearly identified point of contact, PGP or SMIME when reporting. A direct line to a real person who understands security. It's pretty bad when you have to go through tech support to get a security person, but a lot of companies just don't have security programs, so you have to go that way sometimes. But that's why having security contacts in those companies are so important. Clear communication, acknowledgement would be nice when you send the advisory or when you send the bug out to the company. Acknowledgement that you get the email, things like that you've tested on the different platforms, any release dates. Hopefully the company has some plan of what they're going to do with this bug and they're able to share it with you and be transparent about that. Variant investigation, relatively prompt fixes. Like I said, it goes back to the company, resources, things like that, bureaucracy, for example. But these would all be good things that we could see that could be improved on when we're submitting bugs, both from the finders and the vendors. So, any questions? Yeah. Might have went a little quick, plenty of time for questions. Did that completely on purpose. Just raise your hand and someone with a microphone will come find you and maybe high-five you.
Hello.
Yes.
Do you think the VR programs are also interesting for companies whose main business is not selling technology, like banking, pharma, or things like that?
Definitely. The rise of bounty programs has definitely made a lot of things that, well, banking, for example, they're not directly into security, but definitely I think they care a lot about security, or beginning to, because you're going to lose customers if you can't keep your data secure. So yeah, I definitely think that even if they don't have a standard security program or a lot of security processes in the company, that they should care more, and especially if they want to keep customers these days, security, there's a big deal about keeping your data secure, and they should definitely care about that if they want to stay in business. More questions?
Hi.
Hi.
So, if I understand it properly, you are acting like a private broker for the Microsoft employee community regarding managing vulnerabilities against third parties. So, how can you provide an independent view of how well the industry is doing managing vulnerabilities in technology and how mature we are? Based on all the different samples, I guess you are managing every day.
Yeah, I think that a broker in the sense of, we do provide coordination between the parties. I think that a lot of other companies do have maybe similar programs that are helping people that just have security as a hobby or just finding bugs on accident actually get to the right people to get the bugs fixed. So yeah, I do think that it is making an impact. I think that there's been a tremendous amount of bugs in the last couple of years. Since the MSVR program started, it took a year or so for it to pick up. I think a lot more people have become interested in finding bugs in third-party programs, anything outside of Microsoft, while they're at Microsoft, and securing the ecosystem, making sure bugs are getting fixed for stuff they use every day. So I think it has been successful, and I think there has been an impact in the industry, and hopefully, I mean, in lieu of this talk, starting your own third-party coordination program in your own software company will become more prevalent as well. More questions? Plenty of time. Great. Thank you very much. I appreciate it.
Thank you so much.
Yeah, thank you. Sorry.